Hello, I'm Man Chow. You can call me Kenneth Chow. Today's I'm my topic is my quantum gravity series video 28. Today's topic is dark energy. Um, Dark energy has always been a mysterious source of energy of unknown origin. Most physicists attribute it to the Einstein's cosmological constant lambda. Actually, Einstein used the lambda, the cosmological constant, for the sole purpose of balancing his field equation. This field equation is G mu nu minus lambda mu nu lambda G mu nu is equal to minus x pi g divided by c squared bracket T mu nu minus half G mu nu T. That's the equation. Pointed by my finger. This equation is the Einstein field equation because Einstein discovered that his equation, under this equation, there will not be a balancing universe. That is, the universe either contracts or expands. So he is in favor of a status quo, a stable equilibrium. So he added a constant lambda T mu nu to the equation to balance the equation. There are two reasons for the mystery and the unknown origin of the dark energy. First reason is the dark energy is invisible. That's of course a very good reason for it to be called dark energy. And second reason is that there's no concept of the origin of dark energy has so far been discovered. Regarding reason 2, I think this is no longer tenable, no longer a tenable reason, because due to the development of astronomical observations, there appear a myriads of origin or sources of the feedback of energy from the material massive part of the universe to the empty spatial part of the universe. And now such sources are now known. These are: 1. The released energy from the infinite number of stars, on the whole, evenly distributed in the universe. The survey report as at 2012 from NASA's Wilkinson Microsoft anisotropic probe, abbreviated WMAP satellite data. The data from this probe of the NASA is that there are now 1 trillion, as 2012, is that there is now 1 trillion galaxies approximately in the universe, which encompass hundreds of sextillions of stars. This is somewhat a hazy description because hundreds of sextillion. It doesn't say any definite figure, doesn't say 100 or 300 or 600 or 800. It just says hundreds of sextillion. One sextillion means 10 to the power 21. 10 to the power 21 is one sextillion. So I take it that hundreds of sextillion means 10 to the power 24 stars in the universe. Of this number of stars, our sun is a typical one, just a typical one of the stars. Our sun releases 5.96 times 10 to the power 14 joules per 0.00663 kilograms of mass, which it converts to energy by fusion per second. And the sun converts 4.6 million tons of its mass per second to energy. That is, it releases per year. It's very easy to calculate per year. If per second, then multiplied by 86,400 seconds per day, and then multiplied by 365 days per year. So it converts to 1.304 times 10 to the power 34 joules of energy to the space per year. The sun releases such amount of energy to the space, surrounding space per year. Thus, for 10 to the power 24 stars, they together release 10 to the power 58 joules of energy to the spatial part of the universe. And this is equivalent to roughly, approximately, 1 trillion suns, the mass of 1 trillion suns. 10 to the power 58 joules per year means it releases a mass of approximately 1 trillion suns to the universe per year. And in addition to the stars, there are other sources of energy released to the universe. These are 1, supernovas, 2, Seyfert galaxies which violently eject matters from its poles to the universe. 3, black holes. Black holes also sometimes eject strong jets of energy or matters from its poles. And even if it does not eject such jets, it ejects halos. Halos, that means a fog a fork of such matter or energy. And releases of energy from these sources, that's to say the supernovas, the Seyfert galaxies, and the black holes, are much more warping than from the stars. Much more warping. But however, there's no data of how many Seyfert galaxies and supernovas and black holes in the universe. There's no definite number. And then there's also no data of how much energy these structures, these universe structures, release to the surrounding space per year. Now we come to the reason one, that is to say the dark energy is invisible. This is both analogous and dissimilar to dark matter. Analogous because they both are in the outside the visible spectrum of the light. The dark energy is invisible because the energy after release is spread out in the form of waves. And soon, when the wavelength of such waves exceeds 6.56 times 10 to the power minus 7 meters, which is the visible spectrum. That is, this 6.56 times 10 to the power minus 7 is the faintest part of the red light. Then, because it's spread out and then it soon exceeds this spectrum, this wavelength, then it enters into the infrared part of the spectrum and then become invisible. Except using the infrared light telescope to detect it, otherwise it cannot be detected. But being invisible doesn't mean it does not exist. Remember the law of conservation of energy. Energy is always conserved. It never perishes or disappears. In fact, this diffuse energy continues to spread into the spectrum of microwave, and then to the spectrum of radio waves, bigger and bigger. That is, the wavelength becomes longer and longer, and its temperature becomes lower and lower, colder and colder. And in my video 16, I have calculated that the radiation from the sun when spreading to the moon reaches a temperature of 1.5315 times 10 to the power minus 14 degree Kelvin. And when it spread to the Pluto, it reaches a temperature of 3.8607 times 10 to the power minus 16 Kelvin degree. And on spreading to Andromeda, 2.5 million years, 2.5 light years, 2.5 million light years from Earth, it becomes 9.691 times 10 to the power minus 26 degree Kelvin. under such cold, near absolute zero temperature, the outward pressure from this radiation can no longer resist gravity. Gravity takes over, and the wave begins to contract. The end result is Planck black hole, the black holes of a Planck mass and Planck length radius, which is the you have followed my previous videos. You know that the centers, they are the cores of hydrogen atoms. They are not hydrogen. They are not synonymous with hydrogen atoms because hydrogen atoms much bigger. The outward surrounding of this Planck black hole is a hydrogen atom. The hydrogen atom is 10 to the power minus 15. The proton, reckoned from the proton, is 10 to the power minus 15 meter, whereas the Planck black hole is 10 to the power minus 35 meters in wavelength. So they are not synonymous. The Planck black hole is situated in the center of the hydrogen atoms. The hydrogen atoms are the element number 1. These are formed by contraction under gravity. They are formed in the periphery of the Milky Way, and they are even formed in the periphery of our solar system, as observed by astronomers. In short, everywhere in the universe. That's our Milky Way, and our Sun is only an example of the entire universe. This hydrogen element, called the 21 centimeter hydrogen by astronomers, they have observed this. They fluctuate between 21 centimeters wavelength and 1.216 times 10 to the power minus 7 meter wavelength. This is called the 21 centimeter hydrogen by astronomers in wavelength. And in my video 16, I have hypothesized a model of the cycle of the evolution of the universe. In that video, I call it the creation cycle. That is, it's from the radiation of stars, supernovas, galaxies, the radiation of stars, supernovas, and Seyfert galaxies and black holes. It contracts to cold. It expands out, I should say, expand to cold radiation waves. And then this cold radiation wave, being unable to resist gravity, collapsed to Planck black holes, the centers of hydrogen atoms. And these also under gravity. These hydrogen atoms accumulate to become gas nebulas, gigantic nebulas. And then within this gigantic nebulas, stars were formed. This is traditional astronomy. And then when there are enough stars, gravity again aggregate them or to galaxies. This is the simplest model of the cycle of the evolution of the universe ever hypothesized by anyone. I've seen all this, but all of them are much more complex. And this model has the point of superiority because it's 100% from known facts. That's to say, from the energy released by stars, etc., to the space, and then it becomes too cold and is contracted by gravity to blank black holes and with the formation of hydrogen atoms, and then hydrogen atoms under gravity form nebulas. Within the nebulas, the gravity again forms stars, and that's the cycle. The stars again radiate energy to the universe, and then start the cycle again. So this is the whole cycle. That's just so simple, and it's almost 100% from known facts. Nothing from any hypothesis or speculation, except if you say that the blank black hole is a hypothesis only. Otherwise, there's actually no speculation at all. And now I come to the point. I have said that the dark energy is analogous but not similar to dark matter. Now, what do I mean by that? Is they are analogous because both of them are outside the visible spectrum. When the dark energy spread in the form of waves, when it exceeds the 6.56 times 10 to the power 7, the visible spectrum, then it becomes invisible. At first, it's visible because the sunlight was invisible. It's visible, and the jets from the black holes, jets from the Seyfert galaxies, and the supernovas all are visible. At first, it's visible, then it becomes as it spread out and exceeding the visible spectrum, the upper limit, then it becomes invisible. But the dark matter itself is within the ultraviolet ring spectrum, and so it's invisible at first. But because it's still not within the, it's not down. The wavelength is not within the spectrum of electromagnetism. Then so that's why it cannot be seen. In this fact, I refer again to my video 16, and there I have said that it has to reach, in order to generate a small current of 2 electron volts, or 3.204 times 10 to the power 19 joules. It has to have a wavelength down from 0.987 times 10 to the power -7 meter at a mass of 3.56 times 10 to the power -36 kilogram. That's what I said in my video 16. And also in my video 27, last video, I said the smallest current which can be detected electronically by physicists or astronomers is 2e divided by h. The Josephson electric, I call it electric flux quantum. In order to have this small current, you must contract. The energy must contract down to this, from this 0.9767 and 10 to the power minus 7 meters. Otherwise, it's not enough to generate a small current to be detected electronically by the astronomers and the physicists. So, because the dark matter has still not reached that wavelength, therefore it cannot be detected. They are different. They are different, dissimilar. Dark matter and dark energy is different in this respect. One is it has already exceeded the visible spectrum. The other is it's not yet down to the spectrum where it can be detected electronically. That's the only difference between dark matter and dark energy. I think I've stopped here. If you're interested, you can subscribe or give me a like. So I've stopped here. Bye bye.